Hello, my name is Pete Castillo. I'm a junior and a comp sci major.
Hello, my name is Cameron Tafani. I'm also a junior and I'm also a comp sci major.
Hi, my name is Emilio Munoz. I'm also a junior and also a comp sci major. Yeah.
All right, so today we're going to be taking you through our um, network design for Project One. And I first just want to talk about the motivation for the network. So after we read the project description, we kind of just threw a few ideas in the air. Didn't really know what we wanted to do. We were thinking maybe like a small business or a hospital, but we didn't really know how to approach that and how complex it would be. So then we kind of decided on a school, maybe a college, and then we thought like, why not just do SMU? And then we realized that might be a little bit too ambitious to do the whole campus. So we decided to just do a few of the buildings. I think we picked seven buildings in like the upper half of campus, pretty much surrounding Junkins where our class is, to model it after. And what we have is not like a whatever to scale model. Obviously, we don't have like a million computers and different networks, but we kind of simulated like how it would look like and how it would function. Um, and yeah, it definitely taught us a lot about how like a college campus network would function and how like complex it could be. But yeah, so pretty much starting off with the whole process, the first thing we did, we kind of just we looked at a map and kind of mapped out where all the buildings were, and we kind of started off with a physical layout in the physical mode of Cisco Packet Tracer, and just kind of place all the buildings there, and then we just went to the logical view and kind of place the devices in that order. So we just put switches there, we put routers, kind of thought about everything that we would need, all the computers, printers, all the end user devices we need, and then we kind of brainstorm from there, like, oh, okay, we need another switch here, or we need a firewall here, and then we kind of went on from there, and then we just connected all the buildings with wires. That's pretty much where we started, and then after that, it got a lot more complex with configuration, and I'll let you guys take over from there.
Okay, so I'm going to go ahead and share my screen for Cisco Packet Tracer. Can you guys see?
Yes.
Okay, perfect. So basically, looking at everything as a whole, this is the layout of our system. So right here we have Dallas Hall. This is kind of our hub where we have both of our core switches, which bring everything together. We have Deadman over here to the left, and underneath that we have Umphrey and Virginia Snyder, which is a common. We also have Hughes Trigg, Junkins, and Cox. So to start off with, Deadman is one that I configured, and as you can see, it has an access switch, a distribution switch, and an access point. As of right now, the access point isn't really doing anything since all of our laptops are connected with wires, but it's theoretically just there for, any students that had mobile devices or anything like that. The laptops are connected by switches, and as are the PCs. The laptops are connected to the switch, as are the PCs. Everything is connected to this main access switch here. We started off by assigning VLANs to this access switch. So just telling it VLAN 10 is going to be for students, VLAN 20 is going to be for faculty, and VLAN 99 is going to be for management. We learned that configuring VLANs on multiple devices can be quite complex. So that's why we just decided to keep it kind of simple with these three. Um, and we wanted to separate student devices from faculty devices because we know that they are separate, but we still wanted them to be able to communicate with each other, which is why we configured inter-VLAN communication later down the road. But just to start off with, we just configured the access switch to know all of the VLANs that we wanted to have, students and faculty, and then we assigned certain devices to their respective VLANs by looking at the ports. So if I hover over here, it should tell me what port this one is. So laptop 3 is plugged into FA06. So we would then use the access switch command line, which is like right here, and we would enter commands to assign that specific laptop through its port to VLAN 10. So all of these laptops are on VLAN 10 and all of these PCs are on VLAN 20. Then we trunked the access switch to the distribution switch so that the distribution switch is also able to see these VLANs and the devices that are on each one. You don't have to go ahead and reassign them on the distribution switch once you trunk the access switch and the distribution distribution switch, it's able to see which devices you've assigned to each VLAN. So at this point, once we have all of those assigned, we went in and for each device, we went to its IP configuration. We set the IP address. So as you can see, this laptop, which is on VLAN 10, is assigned, this number is 10 right here. And same respectively for a PC and its IP configuration, this number is 20. So it's respective to the VLAN that it's assigned to. And so at this point, the subnet mask just fills in automatically, but the default gateway doesn't come into play yet. We don't need this to communicate just from devices on the same VLAN within the same building. So before we even had that set, we were able to ping from laptop 1 to laptop 2, and we could see that this comes up as successful. In order to allow devices of the same VLAN but in different buildings to communicate with each other, we needed to trunk the distribution switch here to the core switch in Dallas Hall because this is the switch that connects all of the buildings together. So without this, there's really nothing. We could have the same VLAN on Humphrey and on Deadman, but they don't have any way of communicating with each other. So we keep the names the same and we assign VLAN 10 and VLAN 20 to this core switch over here as well. And then we trunk each distribution switch in each building to the core switch in Dallas Hall so that they're able to communicate with each other. And at this point, once that was all configured correctly, we were able to ping from laptop in one building to a laptop in another building since they're on the same VLAN. And we were also able to ping, say, a PC from one building to a PC to from another building. We also configured printers. This one is respective to, oops. Printer 1 is for students and printer 2 is for faculty. So when we did end up configuring inter-VLAN communication, we actually didn't include the printers in these so that printer 2 cannot be used by students and printer 1 cannot be used by faculty. So if you can see here, if we try and send a packet from laptop 3 to printer 1, it should work. But if we try to send a packet from laptop 3 to printer 2, it should fail because it's not set up to be used by students or people on those VLANs. But to configure inter-VLAN communication, we had to assign IP addresses on the core switch, and this is where the default gateway comes in. So the default gateway right here, as you can see, it's kind of similar to the IP address where it has this 10, and for the PCs, it's going to have this 20. And we basically tell the core switch that devices that have that default gateway are on 10 and devices that have that default gateway are on 20. And this allows them to communicate with each other. So after doing that on the core switch, we're able to send packets from laptop 1 to a PC, even though they're on different VLANs. We see that that was successful. And you can see this throughout the network that you're able to send packets from laptops to PCs, and it should be successful. And so, yeah, that was my configuration for Deadman, and it's essentially the same for Humphrey and VS. As you can see, VS doesn't have as many PCs because there's not really faculty in there. It's just really a student dorm. We did know that there is a kind of help desk in VS, so that's why we added these 2 PCs just for the people who are working there. But yeah, similar to the other one, this printer is only configured for students, so it should only be able to be used by those on VLAN 10. And it's pretty much similar throughout the network, but I think Emilio might want to talk about the buildings he configured.
Yeah, so I think communication between devices was important, but especially as you can see here, communication between us as a team was also like excellent. We talked throughout the whole from the I guess from the whole from the start about how we were going to plan everything. And as you can see throughout all of the buildings, we followed a star formation in order to keep things more organized. So overall, the general trend is that on the left we kept all of the laptops. On the right, we generally kept all the PCs, and usually in the middle, we kept the switches, right? And the printers usually in the bottom. So Cameron did a great job of configuring the whole left side and a majority, if not almost all of the Dallas Hall. I was able to configure. Beakus was setting up the devices and the physical layer, which we can point at in a second. And for me, I was able to configure Hughes Trig, Junkins, and Cox as well. And for each building, kind of like we've seen in the other ones, we based the devices that were needed and the quantity of them based on the use of the building. So as you can see in Cox, there's going to be a bunch of laptops for the students that are using it, and a bunch of PCs as well because there's classrooms and all that stuff. And right now, Cameron, she has control right now of the simulation, so you can see everything was configured to be able to communicate with each other. Also following the same VLAN format where it has VLAN 10 working with students, VLAN 20 working with faculty. So right now, as you can see, all of the tests that Cameron has been running with the packages have been successful, except for the one that we designed to be a failure on purpose, um, between the laptop and the printer. Um, and yeah, it's the main thing. As you can see right there, though, there's a green and orange part. Since one of them is being used, the other one is not, and that helps us with redundancy in case there happens to be a failure, the other one picks up. So yeah, this doing this project helped us a lot, like tremendously learning about the Cisco packet tracer and stuff like that. So yeah, Vikas, go ahead.
Yeah, just to piggyback off what Amelia said, I'll go over and show the physical view in a little bit. Um, Here, give me some. Let me share my screen. One quick note on the addressing scheme. So initially we thought, I'll share my screen first and talk about. Um, can you guys see it?
Yes.
Okay.
Yes.
For the addressing scheme, so initially we were going to do DHCP addressing, and then we spoke with the TA, and she recommended actually doing static IP addressing. So we went ahead and manually did static IP addressing for all the devices, but we understand them like in the real world, like for the SMU's actual network, DHCP probably is used as it just automatically assigns IP addresses for multiple devices, but just wanted to make note of that. So this is our physical view of kind of the layout of the seven buildings that we picked, and I'll go zoom in here. But it's laid out like how it is in real life. We have Junkins here, Trig, Cox, Humphrey, VS, Dallas Hall, and Denman School of Law. And initially, after we created the logical view, all of the devices were basically in Deadman in this one wiring closet. So it was a big mess. Um, but I basically had to just move through with Cisco Pack. I had to just move all the devices to their respective spots. But I'll go through a few examples here, like the wiring closet. So basically in the wiring closet, we put all the switches, the routers. Um, I think yeah, basically just switches, routers, and then for our main building, Dallas Hall, I showed you, we also put the servers and firewall in there. So this was Deadman, like you can see faculty office. There's different things like PCs here and printers, and it's set up with the respective VLAN. So if it's like a faculty PC, it's in the faculty area inside of the building, and if it's a student in the student VLAN, then it's in like the student lab, like in Dallas Hall, for example. But the wiring closet in Dallas Hall, this is our main building. This has the core switches, both of the routers, access switches, firewalls, all servers. So everything's kind of set up on this rack here, and it's kind of connected to everything else. There's the student lab here. The access points are in all either the admin office or student lab for all the buildings. And again, everything is connected through there. Um, we can go to Junkins as another example. So the faculty office, they have their own PCs and access point. I put it there for Junkins, wiring closet. Besides Dallas Hall, they pretty much all just have access switches and distribution switches, and then the classroom again just has laptops and PCs. So yeah, the physical view kind of gives you um, a kind of different perspective on the whole network as a whole. But yeah, I pretty much, my main part was designing the network, connecting all the cables, kind of laying it out, and then a little bit of configuration, but mostly just designing the network and then creating the physical view. But yeah, that's pretty much all I got.
All right.
Um, yeah, I think
Sweet.
it's covers everything. Thank you.
Yeah. Thank you.
Bye.